Help for number 14, compliments of your block 2 friends. Here's how it goes. In order to make this work, I cannot directly substitute negative 3, we've discovered, into this directly, because we found out that some of your mates tried that. That would cause division by 0. But this whole thing would totally work if we could just get a factor out in x plus 3, make this x cubed plus 27 into something that's x plus 3 over x plus 3 times some other polynomial. The reason being that I cannot put in that negative 3 because of that particular factor. That negative 3 causes me to divide by 0. So what I'd like to do is have that cancel. Right, Luke? So I'm going to get that to cancel. The process of making this happen so I could cancel these out and get a new polynomial, 1 over something something, requires long division. So let's back up a little bit and clean this up. So the goal is to factor out an x plus 3 in the denominator, and we do it this way. I'd like to figure out what happens when I divide out an x plus 3 out of x cubed plus 27, and we're going to do long division. And remember, long division, you have to include all the powers of x, or you get a little mess on your hands if you don't. Okay. There it is. How many times does x go into x cubed? It goes in x squared times, and then you multiply x squared times x plus 3. We get x cubed plus 3x squared. Then we subtract, and we end up with negative 3x squared. Bring down the 0x. Figure out how many times does x go into negative 3x squared. So if you're wondering where I'm at, right there. It goes in negative 3x times. We multiply by that negative 3x times x plus 3, and we get negative 3x squared minus 9x. And then we subtract, which means change the signs. And we get 9x for sure. We bring down the 27 like this. And figure out how many times x goes into 9x. It's 9. We multiply by 9 and 9x plus 27. And subtract, because that's what we do. And get 0 means we've just factored the denominator. X cubed plus 27 is the same as x plus 3 times the quantity x squared minus 3x plus 9. Right? All right, so I'm going to take all that and put it back together. By the way, I'm not writing anything for 14, 15, and 16 because I've run out of room, but I can rewrite all this. So here's what I got. This is what I just found out. The limit as x approaches negative 3, you must always write the limit. I'm not really very good at remembering that, but I'm trying to say it out loud. X squared minus 3x plus 9. There we go. We just factored that dude. We just split it up. And the reason that's so awesome is because now the plus 3's cancel, and I can directly plug in negative 3. No problemo. And look what you get. Plug in your negative 3. Go mental math on this. You can totally do this. That's 9 plus 9 is 18 plus 9 more. I get 1/27th. Crazy, huh? This limit is 1/27th. That's the power of factoring. If you can get that thing that causes you to divide by 0, the factor that causes it to cancel, you are home free. Rough tough, that's a good one. Others that you thought were particularly tricky. I know one, and we're going there now. Oh yes, we're going there. We're going to the last one on the page. I need a new page. I think I cut it off, didn't I, in my last one? Did you guys say there was one missing? The very last one. All right. Let's do this. New page. Let's add one right here. We're going to make it a blackboard page because I like blackboards. They're cool looking. Okay, I'm going to write in yellow. This one. You're going to have to read it off to me. I think you guys have... Ooh, let's do the squared one first. X plus h squared, right?
Minus x
minus x squared over h. Now the approach, thank you very much. That process that we do for this one, you guys know the limit I'm talking about? Find that in your limit sheet, the one that I gave you today. We FOIL this out and cancel. We use algebra at our best. We have x squared plus 2xh plus h squared from FOILing the first one, minus x squared, all over h, and I forgot to put in my limit, so don't forget to put the limit, blah, 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 blah. Now what I've just discovered is that, oh, those cancel. Okay, so thanks for the enthusiasm over there. It's almost like you're playing a game. You're so excited. Cancel, cancel. Then I've got limit as h goes to infinity, or 0, I'm sorry. All I've got is 2x h plus h squared over h. At this point, I factor out an h. You always look for common factors you can pull out, like an h. 2x plus h remains over h. And therein is the beauty of this process. You want that denominator issue, the thing that's making you divide by 0, to cancel. Gone are the h's. The end result is that I get the limit as h goes to 0 of 2x plus h. And I can now put 0 in directly. This limit is 2x. Now what's interesting is that's a polynomial. This happens. What that means is for any value of x that I want to put in there, I've found something interesting. Believe it or not, this is called finding the derivative. And this is something that we spend all of our first semester of calculus doing. Finding the derivative. You just did it the long way. So that process, I just need you to be able to simplify. Tomorrow, I explain what you found and why that's of importance. But that process is pretty fun. The x cubed one, just so you know, so you guys don't freak out, let me give you another page here. The one where it's cubed, the x plus h quantity cubed. If you want to FOIL that one out, those of you who saw me, it ends up being x cubed. You can use the Pascal's triangle to make this happen. But it'd be 3x squared h plus 3xh squared plus h cubed is how you FOIL that one out. You can do it by hand, but that's the inside scoop. You can now simplify the one on the other limit, factor out an h, cancel the h, and get the result just like we did in the last one. Okay, so that's your hint. You should be able to finish all of that. Right now, the My Math Lab, do what you can and learn what you can. We're going to piece it all together this week. I'm trying to figure out how we'll do that. I hope there's some time to make some class headway. I'm going to pump them all back.